A 5 3/8 inch water pump has a peak efficiency at 35 gallons per minute with a head of 95 feet and a brake horsepower of 1.5 horsepower at 3,500 RPMs. Calculate the flow, head, and power coefficients. So what we're going to do here is we're just going to use those equations that we talked about earlier. But the first thing I want to do is I want to convert over all of these numbers into into numbers that are prepared to be used for the dimensionless parameters. Because things like gallons per minute, well, we're not going to want that. We're going to want cubic feet per second. So let's start and take a look at, we'll start with Q. So it's 35 gallons per minute. So I'm going to look up in my engineering manual, 00223 cubic feet per second is 1 GPM. And so I calculate that out, and I will get 0.78505 cubic feet per second. And then I'm going to look at my RPMs. So RPM's 3,500, and that's a revolution per minute. So I'm going to have 1 minute divided by 60 seconds to get rid of that minute. And then I'm going to have 2 pi radians. There's 2 pi radians in one 360-degree circle, or 1 revolution. And that's going to give us 366.5 radians per second. And the last thing that we're going to look at is we're going to look at our diameter. 5 3/8 inch isn't going to work. 1 foot is 12 inches. That will make everything cancel out correctly. 448 feet is my diameter. Okay, so now we can just directly calculate out our coefficients. We'll start with the capacity. C sub Q is Q n d to the third. So Q 0.785 cubic feet per second divided by 448 feet cubed, and then 366.5 rads per second. And if I bash that in my calculator, I'm going to get a coefficient of capacity of 0.024. And then we just go right to the coefficient head. GH divided by n squared d squared. We are dealing in the English system, so 32.2 feet per second squared. Times head. Our head we didn't have to do anything with because it's just 95 feet. Divide that by 366.5 rads per second squared, and 0.448 feet squared. So just taking a look at that, I've got feet squared on the top, feet squared on the bottom, second squared on the top, second squared on the bottom. All my units cancel out. And then if I bash through that, I will get a coefficient of head of 0.113. Finally, we have the coefficient of power. Coefficient of power is brake horsepower divided by rho, n cubed d to the fifth. Now, we specified it was a water pump, so we'll be able to look that up. And of course, I take a look at things, and I talked about we dimensionalized everything to make sure it was ready to go, but I forgot to do brake horsepower, because we'll just do that right in the thing, because remember, it's 1.5 horsepower, but a horsepower is 550 foot-pounds per second to 1 horsepower. Got to make that conversion there. It's not going to work out. And then I have my 1.94 slugs per cubic foot. It's my density of water. 366.5 radians per second cubed. And then 448. That's feet to the fifth. Now, as I'm taking a look at that, I have slugs down here. I've got foot-pound. I've got force of pounds there. Got to remember that 1 pound force is equal to 1 unit of mass times 1 unit of acceleration. So if we actually work through all this, it comes out unitless. I'm not going to work through it here. You're more than welcome to. But what we'll get is 4.8 times 10 to the negative 4 will be our coefficient of power. So to calculate out these coefficients, the important thing is just to make sure that all the units are going to end up canceling out. And actually thinking about it, I said I wasn't going to cancel them out, but let's go back and just quickly take a look at those. So what do I have? I'm going to write it up here over in the corner. So I had my horsepowers cancel out. So on the top, I've got foot-pounds per second. What do I have on the bottom? So on the bottom, I have slugs per cubic feet. So slug per foot cubed. Radians per second raised to the third. Well, the radians aren't going to matter, so I've got 1 over seconds to the third. And then I have feet to the fifth. So we have to pick one of these and change it. The easiest way is just going to be, since I know pound force is going to be a slug foot per second squared. Seconds cubed, seconds cubed. Get the slug, I've got the slugs. I crossed out the foot, but the slug replaced the pound. And so now as I look at things, I have foot squared here, I have foot cubed and foot to the fifth. That's foot squared, so foot squared, all cancels out. Just going through that to make sure that I wasn't trying to hand wave anything for that, and you guys could see that all the units canceled out.